Topic 7, equilibrium. Dynamic equilibrium. Equilibrium in a reaction is when there are no observable changes over time. This is achieved when the rates of the forward and reverse reactions are equal and the concentration of the reactants and products remain constant. The position of equilibrium. Kc stands for equilibrium constant. The equilibrium constant is the concentration of products over the concentration of reactants. Homogeneous equilibrium applies to reactions in which all reacting species are in the same phase. In this reaction, H2, which is a gas, plus I2, which is a gas, yields 2HI, which also comes out as a gas. The coefficient of HI becomes its exponent and every element is put in brackets. The concentration of solids and pure liquids do not change, hence they are not included in the expression for the equilibrium. It is important to understand what the Kc value means. If the Kc value is greater than 1, then the equilibrium will favor the product. If the Kc value is less than 1, then the equilibrium will favor the reactants. Le Chatelier's principle. When the concentration of the products increases, the equilibrium shifts to the left. If the concentration of the products decreases, then the equilibrium will shift to the right. When it comes to the reactants, if its concentration increases, it shifts to the right. If it decreases, it shifts to the left. When there is a decrease in pressure, equilibrium shifts to the side with the most moles of gas. If there is an increase in pressure, equilibrium will shift to the side with the fewer moles of gas. Temperature is unique because it is the only change that affects the Kc value. In addition, the results of an increase or decrease of temperature depend on whether the reaction is exothermic or endothermic. An increase in temperatures increases the Kc value of an endothermic reaction, but decreases the Kc value in an exothermic reaction. A decrease in temperature will increase the Kc value of an exothermic reaction, but will decrease the Kc value of an endothermic reaction. Adding a catalyst to the reaction does not change the Kc value. It also does not shift the position of an equilibrium system. A catalyst does help a reaction reach equilibrium sooner and lowers the energy of activation of both the forward and reverse reactions. The Haber process. Ammonia is made through the Haber process. In the equation, N2 plus 3H2 yields 2NH3 plus heat. Heat is removed in order to produce ammonia. By doing so, the equilibrium must shift right to go back to equilibrium.